Good morning, good day from anywhere across the globe you are watching. All right, in today's online class, I will be talking about binary operation. All right, and by definition is just all about the combination of two or more elements according to a given rule, yeah, or format. Yeah, that is according to a given rule. So it's the rules can come in any form, but the most important thing is to ensure that you abide to that rule. Now let us say, for example, okay, but before I move further, now binary operation is being denoted by various signs like asterisk, this, it can be this, it can be this, it can be this also. However, it can be either of this sign and probably any other sign. Just for, let's say, for instance, that x operation y can give you, let us say, x raised to power 2 plus y raised to power 2 minus 2xy. Now this is to say that this operation gives birth to this expression, which means you must obey this expression to get the answer for this operation. Yes, now we can also, you can also implement this either of this operational sign for either of this. So we can say x this y is the same thing, x to the power 2 plus y raised to the power 2 minus 2x y. Or you can also say that x using this one, this equals x to the power 2 plus y raised to the power 2 minus 2xy. You can also use this, that x operation y equals x to the power 2 plus y raised to the power 2 minus 2x to the power y. You can also use that x operation y equals x to the power 2 plus y squared minus 2xy. So all these expressions obeys this operation respectively. So, and as such, let us kickstart with some examples. Now looking at this example now the operation this asterisk is defined over R by this, that is x operation y equals x plus y squared. Then we are to in this example now we have that operation this is defined over R by x operation y, which gives us this expression x plus y raised to power 2. Now take note that this is the rule for this operation, or this is the format for this operation. As I said earlier, that a binary operation can be denoted with various signs. Probably in the next subsequent examples, I'll be using other signs. Now here, we have that x operation y equals x plus y raised to power 2. Now find 2. Oh, sorry. 2 operation 3. 2 operation 3. So this, it also implies that that 2 operation 3, it means that here wherever you see x, you replace it with 2, wherever you see y, you replace it with what? 3. So as such, our x now will be replaced with 2 now plus following this sign, then 3. Here we have raised power 2 now, which also gives us that 2 plus into bracket 3 times 3. Yeah, because 3 raised to power 2 is the same thing as 3 times 3. And as such, we get 2 plus what? 3 times 3 will give us what? 9. So it's also implies that 2 operation 3 will give us 2 plus 9, which is what? 11, according to this what? Expression. And as such, 2 operation 3 based on this rule gives us 11. All right, so we'll probably look at other examples, more examples for a better comprehension. All right, now from this example we can see that the binary operation is defined by a operation b equals a raised to power 2 minus b raised to power 2 plus ab. Now take note that this is the rule for this operation, where a and b are the real numbers. Now evaluate the root of 3 plus operation the root of 2. Now, which also, now by solving, we can now say a operation b equals a raised to power 2 minus b raised to power 2 plus ab. So which implies that wherever you see, okay, let's say like this, root 3 operation root 2, which means wherever you see a, replace it with b, root 3. So root 3 all raised to power 2. Now minus, for b you have root 2, so you have a root 2 raised to power what, 2. Now plus, now root 3 times root 2 according to this. So here you have root 3 times root 2. Now also this implies that root 3 times root 3 minus root 2 times root 2, now plus root 3 times root 3. Now why I decided to expand it like this is for better understanding. So here we can now say this is root 3 times root 3 will give us root 9, then minus, now into bracket, open bracket rather, now root 2 times root 2 will give us root 4. Now plus, now this root 3 times root 2 will give us root 6. Now, but we all know that the square root of 9 is will give us 3, then minus the square root of 4 will give us 2. Now plus root 6. So 3 minus 2 here will give us 1, then plus root 6, which means that 3 operation 2 according to this will give us this. All right, now let's move to the next example, which will be the last one. Okay, here's another example, and it says a binary operation asterisk defined on the set of R of real numbers is given by m operation n equals m plus n raised to power 2 for all n, which is an element of R, if k operation 3 equals 7 operation 4. K is an element of R. Find the value of what? K. Now, this example is a little bit different from the two previous examples I've done. Now, this is even far more simple. Now, let us take a look at this. Now, solution. Now, here we have that the operation is given as m operation n, which is m plus what? N raised to power 2. And this we are given that k operation 3 equals 7 operation 4. This means that when you operate this, whatever answer it gives you must be equals to this. All right, in that aspect now, we can relate this to this and also relate this to this. Now, in the same vein, let us replace this for this, replace this for this, also replace this for this, and replace this for this. Now, how do we do that? First of all, what we need to do now, let us work out this one first, which is k operation 3. We give us, now replace m with k, or replace k for m. So here we have that k, then plus, then n for our 3, which is what? 3 raised to power 2, which will give us k plus what? 9. Now, in the same vein, let us work out this. That will be 7 operation 4, which is replacing m for 7 and n for 4. Here we have that 7, according to this, plus 4 raised to power 2, which will give us 7 plus 16. Now, in the same vein, now let us now equate these two according to the expressions here. So here we have that k plus 9 equals 7 plus 16. So k plus 9 will give us 7 plus 16 should be 23. Now, what we need to do here now is to make k the solid of formula, and as such, because we are having 9 here, to eliminate this we subtract 9 from both sides. As such, we have that k plus 9 minus 9 equals 23 minus 9. So this we cancel out this. So here you have that k equals to 23 minus 9, and 23 minus 9 will probably give us this should give us 14. Yeah, so in a nutshell, so this is to say Okay, let me just I guess it's actually not showing from the screen there. Okay, so we can now say that k, okay, from here, sorry, so we can see here that k now equals 23 minus 9, which should give us 14. So as such, now our k value here is 14, now according to this expression. And I hope you understand this. Thank you. Please follow my page for more problem solving equations like this. Thank you.